Assalamualaikum warahmatullahi wabarakatuh. We are from group 2. So in this video, we are going to present and demonstrate the assignment 1 vision system. So this is my group members, Ahmad HAZIQ bin Ahmad YUSOF, Muhammad Hazizan bin Kadir, and myself Nur SOLEHAH binti MAZLAN. Camera calibration. Geometric camera calibration, also referred to as camera resectioning, estimates the parameters of a lens and image sensor of an image or video camera. You can use these parameters to correct for lens distortion, measure the size of an object in world units, or determine the location of the camera in the set. Camera parameters include intrinsic, extrinsic, and distortion coefficients. By using the camera calibrator, we can perform the camera calibration and evaluate the accuracy of the estimate parameters. To estimate the camera parameters, you need to have 3D word points and their corresponding 2D image points. From that, we can plot the relative location of the camera and the calibration pattern, calculate the reprojection errors, and calculate the parameters estimation errors.
Okay, for the camera calibration parameter, there is two parameters, which is the intrinsic and extrinsic. For the extrinsic parameter consists of the rotation R and a translation T. The origin of the camera coordinate system is at its optical center, and its x and y axis define the image plane. For the intrinsic parameter include the focal length, the optical center, also known as the principal point, and the skew coefficient. Okay, for distortion in camera calibration, the camera metric does not account for lens distortion because an ideal pinhole camera does not have a lens. To accurately represent a real camera, the camera model include the radial and the tangential lens distortion. So we can see here there is two type of distortion. The first one is the radial distortion, and the second one is the tangential distortion. For the radial distortion occur when the light ray bend more near the edge of a lens than they do at its optical center, and the smaller the lens, the greater the distortion. So we can see here the distortion, which is the first one is the percussion distortion and the barrel distortion. For the tangential distortion occur when the lens and the image plane are not parallel. The tangential distortion coefficient model these types of distortion. So we can see here the zero tangential distortion and the tangential distortion. It's very different between of these two distortion. So next we will show you the result that we get.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad bin YUSOF. Number 3 DE190. Here I will demonstrate assignment. Assignment 1 is camera calibration. So here we go to apps. Then we choose camera calibration. Okay, then so we wait. Okay, here we click add image. So we go to my sample 1, sample HAZIQ. Okay. So we choose 10 picture with a different angle. Here we click open. Okay, and then we click OK. So here we wait to analyze the image. So here is my image with a different angle. After that we click calibrate. So here we see you get a different angle and a different height also. Okay. After that, we export a camera parameter and generate MATLAB script. then we need to click run, save my project under my assignment 1, sample HAZIQ. So we click vision. Okay, then we click save. Okay, change folder. Okay, wait. Okay, this is the output. So here is the transition vector for my image, and this is the rotation vector. Okay, that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazizan bin Kadir, number metric DE190120, and I will explain about the assignment vision system, which is the image processing. So the software that I'm using for this assignment is MATLAB. So from the MATLAB, using the camera calibrator. So on the camera calibrator, I can insert the picture that required on the assignment, which is the minimum of the 10 picture of the checker box. So here is the picture of the checker box. I insert it. So the size of the checker box square is has been instructed on the assignment, which is on 25 millimeter. So then okay. So we can see here the MATLAB is detecting the checker box. Okay, now from here I will calibrate each picture to get the graph and the data on the position, the position and the angle of the camera that I capture. So here is the graph of the reprojection error. So we can see here the overall mean error is 1.81 pixel from the 10 picture, and then there is 5 picture that are over the 1.1 pixel. So from the pattern centric, for this pattern centric, we can see here clearly the position of my camera when I'm capture the picture of the checker box. So here on the bottom is the checker box, and we can see here there is a few position that I'm capture to capture the image of the checker box, and we can see here the position and the range of the camera from the checker box. On the camera centric, this is more like the mean of the picture. So we can see here is the position of the camera and the axis of the checker box. Okay, now I will export the camera parameter to the MATLAB script. So from here we can see there is the image that I insert on the MATLAB. So this is the 10 picture on the which is to define the process. Then I will publish it the script to get the clear picture. So we can see here there is the result from the intrinsic and the extrinsic for the image that I made. So first of all, I will explain the meaning of the intrinsic and the extrinsic. So the difference between of these two is the extrinsic is represent a grid in transformation from the 3D world coordinate system to the 3D camera coordinate system, while the intrinsic is represent a projective transformation from the 3D camera coordinate into the 2D image of coordinate. So for the intrinsic, we can see here, I will zoom it. We can see here this is the result is for the local pixel for the axis x and y, and the principal point in the pixel also, and the radial distortion. Meanwhile, the intrinsic is in three axis, which is the x, y, and z. So first of all is the rotation vector, and then the translation vector in millimeter. So we can see here this the 10 image uh, result on each image, and then is the mean reprojection error per image and the extrinsic parameter visual. Okay, that's all from me. Thank you.
Next, we will continue to my demonstration. So first, we need to open the MATLAB software and click for apps, search for camera calibrator. After that, we need to click the add image and click from file to upload the image that we took from our smartphone. So we need to click all these 10 images and click OK for the size of checker box for 20 millimeters and click OK. So in this process, the software analyze the image of the checkerboard. After it finish the analyze, it will show up at the data browser. Okay, so after the analyzing image is complete, so it will show up the 10 image on the left side, so that we can check whether each image has the detected points and the checkerboard origin. So in the first image, the yellow box is the checkerboard origin, and the green one is the detected points. So you can see each of the image. So it shows us all the detected point and the checkerboard in origin. After that, we need to click on options and choose the 3 coefficients and click on calibrate. So on the right side, it shows us the reprojections errors of each image. So this one is the numbers of the image. So we have 10 image, so it will appear each image of the reprojection errors. So on the bottom one, we can see that this is how the angle of my laptop that I have been snapped by using my smartphone. So this is the angle from my smartphone and my laptop. For the pattern centric, this is the angle of my smartphone to snap the image from the assignment 1 checkerboard. After that, we need to click on parameters and click on generate MATLAB script. So next we need to save first, and I will save it as um,